Dear friends, Maths Aspirants Groups organizes online problem solving sessions to help the students who prepare for different national level competitive examinations like IIT JAM, CSIR NET, NBHM, GATE, etc. As a part of that series, today we have a session on differential calculus, and we have Ms. Viona Dsouza is with us to handle today's problem solving session. Ms. Viona studied her MSc from NIT Trichy and qualified IIT JAM, also CSIR JRF during her MSc with All India rank 22, also GATE exam. And after qualifying all these exams, she qualified Ph.D. interview in many IITs like IIT Madras, IIT Kanpur, and IIT Roorkee. And she opted IIT Kanpur for doing Ph.D. And currently, she joined for Ph.D. in IIT Kanpur. I am sure that today's session will be a nice experience for all of you. She will discuss some problems from the area of differential calculus. We are hoping to have a interactive session. So all dear participants, please actively involve in the discussion. Hope that everyone will have a fruitful time here. And I would like to express my thanks to Viona for accepting our invitation and joining with us. I'm sure that you people have a lot of things to learn from Viona, and as she qualified all these exams with a very good rank and cleared many interviews. So certainly at the end, we will have an interactive session. So you may ask about the preparation and all that at the end. Now she will begin with the problem solving discussion. Okay, so welcome everyone to this program. Welcome, Viona.
Thank you so much, sir, for the introduction. I don't think there is much that you can learn from me, and it's the first time that I'm trying teaching. So more than me giving a lecture, I would like if maximum people just participate and say whatever they want to, so that I can learn more from you actually. So as the topic is differential and integral calculus, so let's start with the word itself. So any idea what do you mean by differential calculus? Anything that comes to your mind?
Study of rate of change.
Okay, that's nice. Study of rate of change. That whole term is that differential calculus. So what is differential there? What is calculus there? Does differential mean rate of change? Yeah, you could say that, like different, difference, change. Maybe. Yeah, that's correct. That's not what I was saying. Yeah. Maybe we'll go with that only then. It's the rate of change, and then calculus is some form of measurement. And we have been studying derivatives like from our 12th standard maybe. But at that time, we didn't have any limit form of definition. Or did we? Hello?
No, we did not have.
Yeah, means we had a vague notion of what limit might mean. We had formulas and everything. And in a 12th standard, it was a bad case because of some problems. We were only taught for a month or something, and it was just a list of formulas for me. But I was lucky that in the time of BSc, we were introduced with this epsilon delta definition of derivatives. And that's what the first line is. So maybe I'll just read it off. Okay, so here is a limit form definition where given any epsilon greater than 0, if you have this particular ratio, that is fx minus fc divided by x minus c, suppose that tends to some number L, then you call it the derivative. Is that supposed to be right? Hello?
Ma'am, can that wasn't clear. Can you please repeat?
Okay, so a certain definition has been given in the beginning. There is a function which is there on the left side in the modulus, fx minus fc upon x minus c. Then you are subtracting L and you are saying, suppose given any epsilon, you can find delta such that 0 less than mod x minus c less than delta would imply the following inequality 1. Then that is the definition of differentiability. That's what is written, right?
Yes, ma'am.
Yes, ma'am.
Yes. So doesn't that ring a bell about the very definition of limit? That is, suppose that you were going to replace your left side fx minus fc upon x minus c with some function g of x, then this would actually be the definition of if limit x tends to c, g of x is equal to L, right?
Yes.
Right. So actually derivative is nothing but it's just a limit. That's what we understand. And at each point C, if this limit is going to exist, then we say that that function is differentiable on your domain. Okay.
Yes, ma'am.
This is something that we know from long back. This was just something that I was trying to recall, maybe mostly for myself, because from derivative, what we remember is maybe slopes, rate of change, etc. But often the very definition in terms of limit becomes useful. For example, to solve this question. So how do we go about solving questions? I would not start by directly solving, maybe let you solve. So I'll just start by reading it. This is supposed to be a MSQ from JAM. All my questions are from JAM only. Yeah. So here goes. Let f from -1, 1 to r. This function is differentiable, and at 0, it takes the value 0. And we have been given the condition that there is an m greater than 0 such that mod fx is less than equal to m times mod x. And you have certain options. So do you think option A is correct? You can openly answer, try, or anything. Am I audible?
Yes, ma'am.
Okay, means don't need to like solve and keep like which all options are correct. Just asking, do you think A is correct?
Yes, ma'am.
Okay, so can you give me some reasoning why? So I will start with asking, okay, what do you mean by continuous? Like last two classes you were doing limit and continuity only, I think. Suppose somebody wants to say that G is continuous at 0. Okay, then okay, if you're not answering, maybe I'll ask whether this is correct. So you want limit x tends to 0, g of x to exist, and you want it to be equal to g of 0. Then you say that the function g is continuous, right?
Yes, ma'am.
Right. So here g is kind of replaced by the function f prime. F prime exists because it is given that f is differentiable from -1 to 1 and 0 is a point there. So first thing, only the value of f at 0 is given. So to know whether this limit exists or not, we'll see that later. But first thing I know to, I want to know the value of f prime at 0. So how do I find this f prime of 0? Otherwise I cannot check. Any idea?
limit extends to 0.
Okay, you're saying put the limit as x tends to 0. Where?
Plus f dash of
Sorry, can you repeat?
and that's the equation like mod plus f dash of x less than equal to m into mod x.
Yes.
We can
We-
approach
This
limit
inequality. Okay, in this inequality.
we can apply limit extends to 0.
Okay.
Then we can like
Mm.
from this we can get like minus of f dash of x less than equal to 0.
Okay, so that implies that the limit exists. Okay, that much is correct. Okay, so if it's not just that, oh no, so I've taken this modulus thing. No, so it's the same thing if it is 0, right? That, so if limit of mod f is 0, then limit of f is also 0 because of 0. Right? So at least we know the limit exists, but what is the value of f prime at 0 then? F is
0.
okay, why?
We simply put in the inequality x equal to 0 since
Okay, so
inequality
you just substitute x is equal to 0 in that inequality, the one which I am putting in a box. Just put x is equal to 0. So because of the limiting argument that the person before gave, we got this condition. And for the second condition, just put x is equal to 0. Then you will get the modulus of f prime of 0 is again less than equal to 0. And that kind of implies that f prime of 0 is 0. So by the very definition of continuity, option A is correct. Okay. What about B? If you think it's wrong, give a counter example. If you think it's right, give an argument. Maybe you could try proving, and if you are unable to prove, then think it is wrong, then try for a counter example. Okay, so suppose that the condition was only this much, okay? Mod fx is less than equal to mod x, okay? And suppose that the differentiability condition is not given to you, okay? Then if something like this is true, do you say that the function is differentiable? No, you have an example. Take fx is mod x itself. But you have to start with a differentiable function. That is why I cannot go with this. And anyways, the condition that is given to me is f prime x. So somewhere where f prime is not differentiable, but right, f prime is not differentiable, but f is differentiable. So what if f prime looked like mod x? Then what could your guess for f be? Or is it not possible to find such an f? Okay, did my mic go off?
No, ma'am, you are audible.
Okay, fine. You need to attack a problem in a reverse manner. No. If I am unable to prove it, then like try an example. I want f prime to look like mod x. What is mod x like? What is f prime actually giving me? Like some form of slope. Like why is f prime not differentiable if it is of the form mod x? Because sometimes it is giving me 1 as a slope, sometimes it is giving me -1. So how did I get this back? So maybe f prime looked like
Ma'am,
this. Yes.
yeah, I was about to say this. Like, we can define f of x piecewise as minus x square by 2 for
Okay.
x less than 0 and
Okay.
x square by 2 for x greater than 0, greater than or equal to 0. Yeah.
Okay. Okay. So we'll go with this thing only then. That is f of x is, then this means that if I take one x outside and keep one as mod x, like it's the same thing, right? Is it? First thing, is it? If x is negative, the mod x part will turn into minus x and it will become minus x square by 2. If x is positive, mod x will remain mod x and it will be x square by 2. Okay.
Yes, ma'am.
Okay, fine. Okay, so we have a guess for a function. Does it satisfy all the conditions? First thing, it has to be differentiable. Okay, I don't care when x is non-zero. There it will be differentiable, right? When x is not equal to 0, f will be differentiable.
Yes, ma'am.
Okay, when x is 0, we may have issues. So what exactly do you mean by differentiable at 0? There was a definition that if the modulus of f of x minus f of 0 upon x minus 0, this limit exists as x tends to 0, then you say that your function is differentiable. So let's just put the values. X mod x, f0 is given to be 0. Okay, no, not given to be. We have constructed the function, so we have to use this only. Minus 0 upon x minus 0, and then there is a modulus. It pretty much works. You will have this thing. And as x tends to 0, this number is going to go to 0. So this tells me that f prime exists at 0 and f prime at 0 is 0. So f is indeed differentiable. So at least the conditions that are given in the question are true, the first condition. And does there exist an m such that f prime x is less than equal to m times mod x? So we went by reverse construction, that we wanted f such that f prime x is actually equal to mod x and that m can be taken to be equal to 1 to conclude that this inequality is also true. Means if this function f that was given to you, if you actually differentiate it, you will get back f prime as mod x, right? Right?
Yes, ma'am.
Yes.
Okay, why is it so? You could, for x greater than 0, what value is there? And then you could differentiate for x less than 0, and f at 0 has been, f prime at 0 has been calculated, which also agrees as mod x. So f prime at x is mod x. So option B is, what is it? Incorrect. Is it? Isn't it? That we have a function which satisfies the above conditions and the value of f prime turns out to be mod x, which is not a differentiable function. So it is not necessary that f prime is differentiable. Okay. What about C? Since we are going by counter examples, maybe it is wrong. Maybe we could try with our mod x only. Then what happened? Our f was like x mod x by 2. Then your f prime was mod x. Oh no, it doesn't work. Because this is differentiable. Like this was our previous thing that we did. Any other example? If not, could we try proving it? So suppose I tell you prove it, then what exactly would you do? No response. Okay, then I would just write the definition down. f of x, f prime x minus f of 0, f prime 0, and I would try to estimate something that is going on here, right? Right? Audible?
Yes, ma'am.
Yes, ma'am.
Okay. We have evaluated f prime 0 also, but even if you just know f of 0, then that's enough. f0 is 0, so this part is 0. Then you have been given this thing to be equal to then f of x modulus f prime x. I don't need to like separate the modulus, I think, not necessary. Modulus fx f prime x upon modulus of x. Okay. Now, I want to show that it is differentiable. I want this limit to go somewhere. According to the data that has been given to me, I will have to try to use it. Because if the data doesn't exist, it's practically any function. What is given to me is mod fx is less than or equal to m times mod x, right? To not forget about it.
Can we apply the limit x tends to 0 here?
Okay. Okay. Limit x tends to 0 is going to be applied. Okay. So before applying the limit, to apply where? How? Okay, you mean to say then 0 also exists, but below also it's a 0 upon 0 form, right?
Yes, ma'am.
Okay, so on like you cannot like equal to type you cannot go because it's 0 upon 0 form. Okay, so this inequality has been given to you, no? So make it look like the left hand side of that thing. No, I mean make the left hand side of this inequality look like that thing. Just multiply with fx, mod fx times f prime x is less than or equal to m times mod x times fx, right?
Yes, ma'am.
Now
ma'am.
there is an
Yes, ma'am.
extra mod x there. Okay. Now you could apply the limit. Right? But what's the guarantee this even exists? The question is f is differentiable. Doesn't that imply f is continuous? And luckily we have been given the information that f of 0 is 0. That is why this thing is going to 0. So the thing which is written above in blue as limit x tends to 0 is supposed to go to 0. This means that f prime is differentiable. That's why this C is correct. Does this need to be repeated? Any issues? I assume no and go further. Okay. What about D? Now this is about f prime square being differentiable. The data is it visible? Hmm. So what was the issue with f prime? Why was f prime not differentiable? Because one thing is we found a counter example. Other thing is when I was trying to write this down, maybe somebody tried to prove it. Okay. Then the only thing that I could get was m. Right? If I couldn't get anything that was going to 0 to conclude that f prime is differentiable or something like f double prime is 0 or something, the only thing that I got was m, and that worked with your mod x thing that m is equal to 1. That constant getting is not going to guarantee that your function is differentiable. You want something on the right hand side after subtracting to act like your epsilon. That is something going to 0. But what's the thing with f prime square? If you have been given that f prime of x mod is less than equal to m times mod x, doesn't this mean f prime of x squared is less than or equal to m squared times mod x squared? While dividing, how many x do you need to prove differentiable? Can you repeat?
By dividing, there is only one mod x. So
There is only one mod x, right? You don't need two mod x here. And it's we have seen initially while proving continuity f prime of 0 is 0. So I can simply write its square to be f prime 0 square, obviously. And yeah, there's no modulus here. It's supposed to be outside. Okay, till here it is fine. Use one mod x, the other mod x stays. And that actually helps you. Now take the limit to conclude that f prime square is differentiable and that the derivative of f prime square at 0 is 0. Is that clear? Okay. So should we go by this way that like each option I tell you to try? Is that way fine? Any other suggestions?
This method is nice, ma'am.
Okay, then fine. Okay, then again, I think by definition only, because I put it here only, this should be the next question. Let's try this out. This is 34. So this is again an MSQ. Okay, the data is given. S is the set of functions which satisfies this property. F is not a particular function given to you. S is a whole set. Anything that satisfies this property is going to lie in this set. And you have to check whether these options are true or not. So first one should be easy. You want to see whether every function in S is differentiable or not. So if you are trying given any f belongs to S, is f differentiable? So to prove it, suppose you want to prove it, what you have to do is you have to take an f, use the fact that it satisfies this condition, and then prove it is differentiable. Because you chose something randomly, this means it is true for every s. And if you have to show it is not true, then in particular find a function that satisfies the property in s. Just one is enough for a counter example, but f is not differentiable. So what do you think? Is A correct or wrong with explanation? So to check differentiability, we
Ma'am.
will, yes.
Can we define f of x is equal to x raised to 1 by 6?
Okay.
And f of y is a constant function where f of y is equal to 0.
No. No, I mean like it's true. F is defined. Means the moment you say what f of x is, f of y is fixed, right?
Oh, okay.
That's y is not a constant number. For all x, y belongs to R. I should read the question once every time. Okay. And what you have given me is a differentiable function. Okay, suppose that you are having yes, somebody was saying something.
Ma'am, can be like square root of like
Okay, yeah. if you want to, that only I was trying to say, if you're trying to do this differentiability, then like square is not us. First guess is just take this thing out. Okay. Then what else can you do here? Yeah, divide. Okay, so I have taken 1 outside from 3/2. What remains is 1/2. Okay. Okay, then suppose that I'm taking limit x tends to y on both sides. Then this side, I'm getting 0. Again, a modulus greater than or equal to 0. And what am I getting on this side? What is this value? F dash of y. And this is for any y. For every y, the value of f prime of y is 0s. This means f prime at y is actually equal to 0. And at each y it exists, that is why f is differentiable. So given any f which belongs to S, you have found it. Suppose instead of 3/2, the number here was 1/2. Then if somebody had done some kind of division, then they would get minus 1/2, right? So after that, you couldn't take the limit. There would be issues, and that may not have been true about differentiability. There are counterexamples, I think. But the main thing is you could get a positive number here because the number that you took here was strictly greater than 1. The point that I wanted to make is, so suppose alpha is greater than 1, and if mod x minus, mod fx minus mod fy is less equal to x minus y power alpha, then you can always apply that, right? If alpha is strictly, yes, then just write it in this manner, and because this number is now strictly greater than 0, that is why the limit can be taken. Okay? So option A is correct. What other options are correct then? See, the concluding point was this. And f has been defined on all of R. R is connected, R is like an interval, and yeah. So okay, do you think option D is correct? Or instead of looking at the options, what can you say from this blue thing which I am underlining? F prime of y is 0 for all y belongs to R.
Constant.
Ah, yes, f is a constant. And so if f is a constant, that is S, you have like now found S literally. S is actually the set of all constant functions then. I think so. Like for every point which is coming from from S, it could be. So is B, C, D, what is true now? So there exists a function f belong to S. This means that there exists a constant function. There is a constant function which is differentiable. Okay, that much is fine, but not twice differentiable. What do you think? Is there a constant function like that?
No, ma'am. I think constant function cannot be twice differentiable.
Wait a second. Constant function's derivative is the zero function, and then zero function is differentiable. And again, if you differentiate it, then you are getting the zero. Maybe I wrongly said something. Is it?
Ma'am, can we say that option D is correct? So B and
Yes.
C will be wrong.
Yes, that's very easy. Yeah, means because every function in S is a constant function. That is why it is infinitely differentiable. We agree with this fact, right? That the constants are infinitely differentiable. They are polynomials after all. Any doubt in that?
Ma'am, like earlier question, there is twice differentiable is not possible. We can construct earlier, right?
In the earlier question, yes, but the condition
like
that
that.
was given was different. The set
So condition was different, but like similar. Okay, so like that way we can think about or not. I am.
there you can conclude f prime of 0 is 0, but you cannot conclude that f prime of x is 0 for all f. There are functions which are satisfying this condition, that is f of x is equal to x mod x by 2, which is not constant. But we by argument concluded that S precisely consists only of constant functions.
Yes.
So if it has only constant functions, obviously they are infinitely differentiable, and that means B and C has to be wrong. There is no issue with differentiability of constants. Should I repeat everything? Or okay, a quick thing. If you are having any such alpha which is strictly greater than 1, satisfying this condition, from that you can divide this thing by x minus y, take the limit as x tends to y to conclude that f prime of y is 0. Given that f is differentiable on all of R and f prime is 0, that will imply f is constant. Given any f belongs to S implies f is constant, right? So B and C have to be incorrect. That also means, so f is constant will also imply f differentiable infinitely. That is why given any f belongs to S, f is infinitely differentiable. That is why twice differentiable, not thrice, thrice, not 4 times. Something like that will not happen, because we have literally found out S. Okay. Okay.
Yes, ma'am. Yes.
If it is incorrect, I don't know, but like the options match actually. The options are A and D. Maybe is my argument wrong, or I don't know, but I think it has to be constant functions only. And we'll see. Should we move further to the next thing? So yeah, I just put it here. If f is continuous on the closed interval, differentiable in the open interval AB, it's an interval. Interval is important. So f dash 0 doesn't imply f is constant, but where you are defining it, like yeah, if you're having something like this, then also your f prime is 0, but f is not constant because your domain is like broken. So if f is continuous on a closed interval AB and f is differentiable on an open interval, you don't need the endpoints. Then f prime of x is 0 for all x belongs to open AB. And no, that's the given condition. Then you can imply that f is constant on I. And there I was acting like R. So sometimes I will put the theory first and like the statement, and sometimes maybe later after the problem. Okay, like this is before the problem. I should continue, right? Okay, I'll continue. Okay, so you have one more theorem here, that if f is differentiable on the interval, then f is increasing on I if and only if f prime of x is greater than 0, greater equal to 0. By increasing, it doesn't mean strictly increasing. Increasing just means x greater than y means fx is greater equal fy. And the other thing is decreasing, that looks something like this. Okay. So you have an if and only if condition on the interval. Interval is again important. And this is true, could be proved using the definition of derivative. And then since suppose that you were starting with increasing, and you want to check whether this thing is greater than 0, like how would you go about proving it? So suppose that one side you are going about C, that is from this side, right side, then x minus C is positive. That is why actually you can take it on that side, right? Or something like x minus C is positive, and given that f is increasing, fx minus fc is also positive. So this is true. Now take the limit and conclude it is true. And also you could go in the reverse direction somehow. Or just remember the statement. Anything is fine. Okay, but the interval is important. So why that theory? Maybe that could be used, or maybe some other method could be used to solve this problem. Please try. If you're good at drawing graphs, you could also do that. I am not that good, so yeah, anything is fine. Any guesses? Even guesses are fine. Option C. So you think that fx minus gx is going to change the sign. Okay, what made you feel that it is true? Like you want to say somewhere it is negative, somewhere strictly less, somewhere strictly greater. Sorry, at pi by 2, can you repeat?
At pi by 2 to 0.
Then the value of f of x is 0 and g of x is 1 minus pi. Okay, this is pi by 2 the whole square, pi square by 4 by 2, pi square by 8. Okay, so is this bigger than 1? Is this lesser than 1? I thought that pi square is 9 point something. 9 by 8 is again a little bigger than 1. I think this is negative. Then
From 0 to pi by 2.
I actually are not audible.
From 0 to pi by 2. Send the positive things.
Okay, in 0 to pi by 2, this is positive. Okay, f of x minus g of x. Okay, I agree with you on that thing. That in between 0 to pi by 2, f of x minus g of x is positive. Any argument you can give for that? Hello? Actually not positive. Yes, yes. Please repeat. I'll write down the functions. I think this is cos x. Yes. And 1 minus x squared by 2. maybe what you want to try, if you were to try it formally, would be just define a function which is the subtraction of these two. If I have to try any of the options, maybe A is true. If I have to check, I will just prove h of x is greater or equal to 0. If I have to try for C and D, then I will find 2 points where h of x is strictly negative and 1 point where h of x is strictly positive. So in any case, this definition makes sense. Then maybe I'll just differentiate it to test the nature of this. Derivative of cos is negative sign. And in between 0 to pi by 2, as you said, x is supposed to be bigger than sin x. And at 0, equal. If you're saying open interval, it is strictly. So h prime of x is positive. That means f is increasing, h is increasing by the above theorem. So the value of h at any x where x is greater than in this interval 0 to pi by 2 only, okay, that would be bigger than h at 0. If you calculate h at 0, you will get 0. So h of x is strictly greater than 0 if x belongs to 0 to pi by 2. But what is h? F of x minus g of x. So we have concluded this. This is what you wanted to say, is it?
Yes, ma'am.
Yes, so at least from 0 to pi by 2, we have a idea that f is bigger than g. And at 0, they meet. What about the negative side? So if you look at the function h carefully, it's an even function. Is it?
Yes, ma'am.
So just copy it down here. Then the upper part is f, this part is g. So actually f is dominating g throughout. And at 0, they meet. If somebody were to actually draw the graph might look like this for the cosine, and then like this for the x square function. But certainly if you cannot draw like me, I can't draw. You could do theory. So is there any issue? It's MCQ. And anyways, if one of them is true, nothing else can be true. Because we have found strictly and they are not equal. So from that you can conclude. Is it fine?
Ma'am, can you repeat for minus pi by 2
Which part?
minus pi by 2 to 0?
Okay. So formally, let's try formally. Suppose that x belongs to negative pi by 2 to 0, then minus x belongs to 0 to pi by 2. H of minus x is bigger than h of 0 then, because minus x is in that interval. You know h is even. So h of minus x is the same as h of x. That is why h of x is again bigger than h of 0 when x belongs to minus pi by 2 to 0 as well. So given any x belonging to minus pi by 2 to pi by 2. Repeat again, should I? What? Okay, fine. Okay, so yeah. Then A is correct. It's MCQ. Don't bother the other options. Where is the next question? Okay, the next thing is theorem. So out of nowhere, no, it's not out of nowhere, but maybe if you look at the next question, these two theorems will come to your mind, and you might have to think which one to use or maybe to use both. So why not discuss it first? Suppose that f is continuous on the closed interval AB and that it is differentiable at every point in, this is like so much well known, differentiable at every point on open interval AB, and that f at A is equal to f of B is equal to 0, then there exists some point C, at least one point in AB such that f prime at C is equal to 0. That's one theorem. And that's a well-known Rolle's theorem. And then there is one more theorem related to convex function. Okay, so I should have put the definition of convex function. You say that the function is convex if it is like x square. What do you mean by like x square? In general, pictorially, if you are going to draw the function, take 2 points, and if this line that is joining them lies above the function, and that is true for any function, any 2 points, then you say that the function is convex. More formally, for any x and y, if f of tx plus 1 minus ty, I think I am writing correctly, is less than or equal to t times fx plus 1 minus t times fy. T should come from 0 to 1, I think. Then you call the function to be convex. If I'm incorrect, you can correct me, because I did not copy paste the theory yet. Is that true?
Ma'am, once more, can you tell what is convex function?
Okay.
Theorem once more.
Okay. To define a convex function, you require to start with a convex set. You say that a set is convex if for any t belonging to 0, 1 and any xy belonging to that set, tx plus 1 minus ty is supposed to belong to the set S. Now, once you have a convex set, you can start with the convex function definition. On a convex set S, the domain, you say that the function f is convex if ftx plus 1 minus ty is less equal t times fx plus 1 minus t times fy. This, I think, means on one side, this is like the line segment joining the point fx and fy, and t is any point there. So the line segment is going to lie on top of the value that is being taken in between. I will clarify this myself and then maybe let you know. For the time being, just believe it. Is that fine? I should have copy pasted a definition of convex as well, I think. Hello?
Yes, ma'am.
Okay, I think it is correct. I'll clarify for sure. Okay, then f is a so this actually, if you're having a twice differentiable function, no, then that makes stuff easy to check whether it is convex or not. There's a proof of this theorem also, but very easy to if you remember it, that f will be a convex function on I if and only if f double prime x is greater or equal to 0 for all x belongs to I. Okay, the feeling that you get from this, the proof is not like this, but you have the above thing that if f prime is 0, then f is increasing, something like that, right? So if f double prime is 0 means f prime is increasing. F prime is increasing means it is going from negative to positive. So f prime being negative means f prime is a slope of some function. Some function slope is negative means it is decreasing first, then going to 0, then it is increasing. Let's go back again. Suppose that this is f. Now let's try reverse. Suppose that this is f. Its slope is going from negative to positive. then f prime is increasing. If f prime is increasing, then f double prime is supposed to be greater than 0, greater than equal to works. So we have a feeling that if f double prime is greater or equal to 0, the if and only if f is convex. It looks like this, I mean. So that's not a proof. There are, just check Bartlett-Sherwood for the proof. You use the another definition of limit of second derivative in terms of a plus h, a minus h, and minus 2 times f at a, and get it. Just believe it for the time being. Fine.
Yes, ma'am.
Is it to be repeated? No. Okay, let's just.
No,
Okay,
ma'am.
let's just do the question. Then just remember, then if it is less than equal to 0, then the behavior becomes like this, like minus x square, like, and it's called concave. Okay. So let's go with the question. Maybe by that thing which I said above or something else of what you like, you could try to solve this question. Question 28 is supposed to be a MCQ, I think. Yeah. And try it.
Ma'am, here we want to find first y of x.
Okay, I don't know what y of x is because it's not a differential equation which I can solve. This is a class of functions, so yeah, I don't know what y of x is. I'm not even good at ODE. Do you know any other way to solve? Please let me know. Is there a ODE way to solve it?
Ma'am, we will get that second derivative is strictly less than x square. That
Okay.
means the function is concave downwards. So since y of 0 is equal to y of 1, we will get that the function has to lie above the x-axis on open interval 0, 1. So y of x is greater than 0 for x belongs to 0, 1.
Yeah. Actually, that is the answer, and this is like the only argument. Whatever he said, exactly same argument I have for that. And then that's pictorial, or saying more like it should lie above. So if someone were to prove it more formally, suppose by chance it went below, then it has to come back above. But the meaning of that happening is it was 0, the derivative, then it became positive. No, positive, is it? No, it's negative, right? Negative. Then it again increased, and then it again became 0. So the behavior of y prime, you can say that there is a certain part where y prime is increasing, that is y double prime is strictly greater than 0. But that's like not true. Well, does that even make sense? What I'm trying to do is discard other options if I cannot prove properly the point A, where A is very clear pictorially. So suppose that it is not true, then there are 2 points where at least one point where it is negative, if A and B both are false, and at least one point where it is positive. Location of roots theorem forces this to happen. And again, pictorially without any proof. So it has to go from this stage to this stage. That is from negative to positive. Who is going the slope? That is f prime. That is f prime is increasing, means somewhere f double prime is greater than 0. But we have a clear thing written that as long as x is non-zero, or even anywhere, your y double prime is strictly lesser than 0. Here I'm talking about y, not f. I do not have a formal argument for the following, actually. Do you have anyone? I wanted to know. Or maybe some ODE way of solving it. The answer is this, which is given.
Ma'am,
Yes?
can you take counter example? Like,
Oh, you have a counter example for A. No, I'm sorry. Okay, just give the example.
ma'am, I will consider a function
Okay, what is the function?
x bracket में 1 minus x cube within
Sorry,
bracket
x
x
bracket
1 minus x cube
squared.
cube ma'am cube x cube x cube
I'm really sorry. Can you tell me from the beginning?
x into 1 minus x cube.
Is this the thing?
Yes, ma'am.
Okay. So y at 0 is 0, y at 1 is 0. If this x lies in between 0 and 1, x cube also lies in between 0 and 1. Minus x cube lies in between minus 1 and 0. 1 minus x cube lies in between 0 and 1. So 1 minus x cube is positive, x is also positive. How is it a counter example? What did I do? This is correct. Did I get your question wrong? Can you please repeat the question? Okay, maybe let's go further with this. In the end, maybe we could come back to this. But if the answer key may be wrong, then I don't know. But the answer key says that the option A is supposed to be correct. I don't know which version I picked. Is that the final answer key or not? And since I do not have a proof and my proof is pictorial, so I also cannot guarantee that you cannot find a counterexample. But let's pause this one then. Okay? Okay. Am I audible?
Yes, ma'am.
Yes.
Okay, okay. Is it okay to postpone that question?
Yes, ma'am.
Okay. So here comes your Taylor's theorem. I think this is because the next question has to do something with the Taylor's theorem. So number of times that f is differentiable is given to be n plus 1. Okay. And for the n plus 1, the derivative to exist, f has to be continuous for sure. F power n, I mean the nth derivative of f has to be continuous, because differentiable implies continuous. So if f's nth derivative is differentiable, that means the n plus 1 the derivative at f exists, then your function has to be continuous, obviously. So why am I repeating that? If x naught belongs to I, then for any x belongs to I, there exists a point C in between x and x naught such that the following happens. So we have a number of stuff like, just write it down. 1 upon 1 minus x is 1 plus x square, etc., etc., etc. You have series for sine x, like x minus x cubed by 3 plus this, etc., etc. So this plus equal to, if you are able to write it, the Taylor series actually just guaranteed stop somewhere here and then get a point, say, in your interval wherever this thing made sense. Yeah, I think something like this may come. Will it or will it not? By putting x naught to be equal to 0 actually, but then there is a remainder, Rnx. And if you are able to show that this Rnx actually goes to 0, then you can write this equality. This equality doesn't make sense in the way, because you don't know how much you are going to add, but the meaning of your right hand side is actually the limit of a sum. Limit n tends to infinity of a certain series, right? So my point was, just be careful while writing the equality. Okay, that's the Taylor's theorem. I didn't even read the statement. That you can write fx is equal to f at x naught plus f prime at x times x minus x naught plus f double prime at x naught by 2 factorial x minus x naught square. In general, you could write your f of x as sum of the form fjth derivative at that x naught by j factorial times x minus x naught whole to the power j. You will stop at a certain point and then have the n plus 1th term. And if you are able to show in general your n plus 1th term is going to go to 0, then just write this as infinity. And then you see that the Taylor series converges to f of x, which I didn't put here. Okay. So maybe that is useful for this question, or maybe some other way. Please try to find the value. I don't think this is an easy question. Usually I won't attempt it. I was trying, I still couldn't find. Then I asked a friend. He kind of solved it for me. So yeah, just keep trying.
Ma'am, I have no idea to solve this.
Yeah, I was also like that only. But you could just start that. Maybe just write f of 3 plus h as f of 3 plus h times f prime of 3 plus what will come? It's given that your function is clearly given to you. So something you know about it, and your domain doesn't even have 0. So it has a feeling of being differentiable infinitely many times. I think so. And plus one more thing, that I think the Taylor series should converge. Just assume that this happens, or not. Do not go too much into the theory, like why exactly it has to be equal. You have just been given that f of 3 plus h minus f of 3, its value can be found in one way by the Taylor series. This is the Maclaurin or Taylor, or okay, it's Taylor only. Where in x minus x naught you put h and obtain this form. Then the left hand side has been given to you. H times what? F prime at 3 plus h times h is h times f prime at 3 plus h square by 2, f double prime at 3 plus h cube by 6, f triple prime at 3, and so many things. Because there in the test, I usually don't bother with the stuff converges or not. I should. Then since one h maybe can be taken outside, just write whatever happens. Okay, now the issue is theta of h has not been isolated. You have two ways. Just put the cube root sign, or like just substitute the value of the function and then maybe try. But I tried that actually and I couldn't solve it. Then later it became a very lengthy calculation that also turned out to be wrong.
And again, we can expand with Taylor series.
Yeah, exactly. That's what my friend did. So assume that f prime is g. Then you would write g of 3, right? Just assume that f prime is g, and you're having g of 3 plus h times theta h. What you would write is g of 3 plus whatever is here is h. Again differentiate. Again write plus sign. Oh, okay, you're having some issues here or not. I don't know. H square theta of h squared by 2g double prime at 3, so on. Just leave it at the Taylor series on both the sides. Substitute g by f prime and write down this side. F prime at 3 plus h theta h f prime prime means f double prime at 3 plus h square theta h square by 2. Okay, what happens here? F triple prime, I guess. Is it? Wait, this is G, then this is G prime, and then, yeah, let's go with that. F triple prime at 3 something something. And what happened? This side, we just copied down. What was that? H F prime at 3. No, H is not there from this line, right? F prime at 3 plus H by 2 F double prime at 3. Then h square by 6 f triple prime at 3. Something something. I'm only interested in the limit of theta h. Cancel this f prime at 3. Divide by h. You get theta h times f double prime at 3 plus h by 2 theta h squared f double prime at 3. What did I do? I cancelled h, right? So half f double prime 3 plus h by 6 f triple prime 3 and so on. Okay, now the whole point is I want limit h tends to 0 of theta h. The thing to consider is everything else is going to go to 0. This term and all the terms which are going to come after that, because the limit exists. We can assume that by the question we are supposed to find it. Okay, I don't know why it exists. It should exist, I think. Then later you will get some cube or something, but along with that you will have a term of h for sure. So everything else in front of it is going to go to 0. Similarly on the second side also. So from there you can actually conclude that limit h tends to 0 theta h times f double prime at 3 is equal to this constant half times f double prime at 3. Okay, is f double prime at 3 0? Okay, what was f now? Fx is cube root of x. So certainly, I don't think that f double prime at 3 is 0. Cancel them.
Ma'am, I have a doubt here.
Yes.
The function given as cube root of x, right? It is not
Yes.
differentiable at 3. So, but f double prime, can it find out?
No, I thought the issue was only with 0. See, it's okay. Let me try. F of x is cube root of x, and this is true for x open interval 0 to infinity. This is x power 1 by 3, right? So when you, okay, how do I scroll down? Okay, f dash of x is 1 by 3 x power minus 2 by 3. 0 is the only point of issue. Again, f double prime of x is negative 2 by 9 x power minus, what is this, 5 by 3. And then you substitute f double prime at 3 is any issues?
Yeah, no, ma'am.
Okay. So if there is any other way to solve it, please let me know. This way that I also couldn't figure it out. I got to know it from somebody else. But the answer is half. Yeah, that's what I know. We'll go to the next question then. Okay, how do I scroll down? 1 second. Okay. Okay, now all of a sudden I'm starting integration. I couldn't find many questions of differentiation. This is differential and integral calculus. Okay, so okay, what do I start with? So here I have not given the definition of LFP and UFP. So in general, we are starting to know something regarding Riemann integrability. So you had to add the word Riemann because there is one more kind of integrability, at least one more kind that I know. This is defined in terms of in different ways, equivalent ways. There are 2 ways to start with. Like some people do it in this manner, that suppose a function is given to you, you partition it. A partition of the closed, it should be a closed interval, okay? I'll just start somewhere. I do not no, I should start with something like, suppose that f is given function, then it's given an interval to r. Okay, I don't know continuous or not. I drew something continuous though. A partition P coming from P of I would be a set of points taking x0 as a strictly lesser than x1, etc., etc. It is finite in nature. Okay, you take till you get xn to be equal to b. These are your points, x1, x2, and your b turns out to be xn. There are 2 ways. One way is you choose a point called as a tag, as in Bartley-Sherbert, and at that point ti, in each xi minus 1 to xi, you choose a ti, and there you evaluate the value f at ti, and you multiply it with the length of the partition, xi plus 1 minus xi, and then just add them. Then you get a certain value called as SFP dot, and for each of your partitions such that the maximum length of the partition, in the sense, what is the meaning of norm of a partition again? So this length that you are taking from xi plus 1 to xi, since they are finite in number, these lengths which are there, they are finite in number, finite real numbers, you can take their maximum. Call it the norm. If the biggest number is going to go to 0, all the other numbers are going to go to 0. In other words, I am making this finer and finer. I am going to choose a point. And as the norm of that partition is going to go to 0, suppose this value that I have defined, SFP over I, goes somewhere. Somewhere in the sense the limit exists and it's a single number. That's the meaning of limit exists. Then the function is said to be Riemann integrable. Similarly, some books define it in terms of upper sums and lower sums. I have to scroll down. Okay, my screen hanged. 1 second. Okay. That one other way is as follows. It started working. Given that interval A to B, you again partition it, but this time you take the supremum in the interval of the function. This point, say. My pen is also not working. Sorry. And then suppose that the supremum that is present from A to x1 is at some value. Here it is at x1 and at different values. Hello?
Hello, ma'am. I have a doubt.
Okay.
In A to B interval, B itself is an supremum, no?
Okay, whose supremum I am taking? The supremum of the value of f. Sorry, I should be more clear. So I'll write it down properly. For x belonging to xi minus 1 to xi, if I find the supremum value of f of x for x belonging to xi minus 1 to xi, that is f.
Okay, ma'am. Clear.
Was your question in interval A to B, is B the supremum? Yes, B is the supremum.
Yes, that is my question.
Yes, obviously B is the supremum. Means in the sense, when you say interval A to B, you want to choose A to be strictly lesser than B. Yeah. Okay, so in the previous way, part of Riemann integrability defined by Bartley-Sherwood, either you start by, I cannot use any other color. I don't know why my screen is not working. I'm sorry, but just bear with me. In xi minus 1 to xi, you choose some ti at random. Then your partition becomes tagged. The sum of f over the tagged partition is actually defined as take the value of f at ti and take the length of the interval, which is xi minus 1 to xi, and add it over all I. You are kind of taking small rectangular areas in that sense. But in this case, you start with taking the maximum value wherever it occurs as your tagged points. Then the thing that you will get is called as UFP for that partition P. That is the upper part of the rectangle. And why this rectangle I'm drawing, the point is f at ti is the y value, the length, and this is the length in this form. When you are multiplying, you're literally getting this area and you are adding up the area. So you are covering your function, I think, from the top. And similarly, you could cover it from the bottom. I would have used one more color, but my screen is not working. It hanged it. Okay. Okay, it just started. Okay. Similarly, if you are going to find the infimum, believe me, you will be able to cover it from below as the partitions get finer and finer, if the value of upper sum FP kind of exists, that is when your partition is getting smaller, these areas are approaching a number, and the lower sum is also approaching a number. That is when you are covering your area curve from below. Then, and suppose that those two numbers coincide, then by Bartley-Sherwood, it is called as Darboux integrability. And since it has been proved that Darboux integrable is the same as Riemann integrable, so one could use this definition also. And many books actually start the way I learned in my MSc, Riemann integration. We had upper sum and lower sum definition. So more formally, if I have defined integrability below this, see, this is Darboux integrable, where LF is defined. Okay, how is LF and UF defined? Here goes the definition. You are taking, as your partitions are getting smaller and smaller, the value of LFP is going to increase, but it is always going to lie below the area. Just believe me. And the biggest value that it can take, that's the supremum, from below, covering by rectangles from below is called as LF. And if you are going to cover it using rectangles from above, it is called as UF. Suppose it happens that the value of LF is equal to UF. Then it is called as Darboux integrable, and it can be proved that Darboux integrable and Riemann integrable are actually the same thing. Okay, any issues till now? Any doubts?
No,
Yeah.
ma'am, it's clear.
Okay, I hope, like, I'm not good at explaining. I'll try better next time. Maybe the above thing would be useful, or maybe some other theorem regarding to Riemann integration to prove for these functions. But I assume you have studied Riemann integrability before. Okay, what are the answers for this? It's a MSQ because it is 35.
Option D is Riemann integrable.
Okay, D is Riemann integrable. So option D is correct. Okay. Any theorem that you have used in that case?
No, ma'am. Only one point is defined as 0, and all other point we have function f of x equal to x.
Okay, so what makes you believe that the function is Riemann integrable?
F of x equal to x is a Riemann integrable function.
Okay, maybe have you used some, maybe you could formally prove that this is Riemann integrable, or you have you just know that this is Riemann integrable because of some property of this f? Maybe continuity?
Yes, if a function is continuous, then it is Riemann integrable.
Okay, okay. Yeah, I wanted to get to that. Riemann integrable, yeah. So because of this, but here the function is not continuous. There is a point where is it continuous? No, it is not continuous. Okay, here there is some issue. Okay.
Continuous.
Okay.
F of x equal to x. So this option D function is similar to f of x equal to x. No.
There are many things that are. What do you mean by similar? I could draw anything else that is similar. Like, I don't know whether it will mean continuous. Okay, similar in what sense? I'm trying to get what you're trying to say. Do you want to say only at one point it is different than a continuous function?
Yes.
Yeah. So for that, we can come back to these theorems. Somewhere I should have written them. Okay, where are they?
If discontinuity is countable, then it is Riemann integrable.
Okay, 1 second. I'll try to access this. Okay, I lost the images. I don't know why. Have I written it somewhere? I think I've written this somewhere. No, this is the fundamental theorem of calculus. Maybe I forgot. No, okay, here they go. Yeah, if a function, you are right that if a function is continuous, it is Riemann integrable, and you are right about that option because of theorem 7.1.3. Let's suppose that you are having a function which is equal to a Riemann integrable function everywhere except for a finite number of points, then that function is also Riemann integrable. Okay.
Yes.
So there's just one point where it's not, so it's because of that theorem. Okay. So from continuity thing, anything about option A, B?
B,
B is correct or wrong?
like continuous it is.
Okay. Okay. So limit x tends to 0, fx is f0, means continuous. This means you want to claim that limit x tends to 0, fx is 0. And do you know how to prove it? I guess you know how to prove it.
To prove that x sine 1 by x is 0.
Yeah. Yes.
By squeeze theorem.
Yes, it's hanging a lot. I'm sorry. Yeah, you could use squeeze theorem, and the fact that this is bounded, and then prove that thing. Yeah, exactly. So option B is correct. What about option A and C?
C is not a Riemann integrable.
Okay, why?
Something like a Dirichlet function.
Okay, it looks like the Dirichlet function, and you know that Dirichlet is not Riemann integrable. Why is the Dirichlet function then not Riemann integrable?
It has infinite number of discontinuities.
So you want to say if something has infinite number of discontinuities, it is not Riemann integrable. Say at each point of the form 1 by n, I put it as 0. Your f of x is 0. What is of the form 1 by n, and else it is like x. I thought that this is still Riemann integrable.
In this question, like it is given in that for rationals and in the
Yeah.
interval 0, 1, it is 1. But like after a particular rational number, we cannot detect the next rational number. So like there are many irrationals in between.
Okay, so if you want to prove it is not Riemann integrable, maybe not by using any result or anything, maybe we could try to use definition. What kind of definition will you use for option C?
Lower sum, upper sum.
Okay, lower sum, upper sum. So what idea that lower sum, upper sum actually means? Okay, good thing this is at least working. You have been given the function f of x to be 1 if x belongs to 0, 1 intersection q, I think, and else in 0, 1 you are having -1. Yeah, it has way too many discontinuities, but that doesn't help you to conclude that it is not Riemann integrable. It means you can, but you have to formally prove it. Then if you have to find upper sum, you have to start with the partition. Randomly take any partition that you would like. Upper sum means, oh no, what happened? Wait a second. Okay, it started working again. Okay, I'll write it here. Again, you are having 1, you are having -1. Then you are having from 0 to 1, I think. And if you have to calculate upper sum, you have to take a partition. Randomly take any partition P. Take the supremum value of the function. The function, you cannot draw it. But the supremum value in any interval is 1. Then you are supposed to add up the value times xi plus 1 minus xi. And while adding it up, you will get the length of the interval. That is 1. So for any partition, since the value of UFP is 1, that is why UF, which is actually the infimum of all possible UFP, also has to be equal to 1. Do we agree with this? Oh, something happened.
Yes.
Okay. Again, yeah, here. Then I'm very bad at writing. Now this is not working. Great. Okay, just believe me, whatever I say, then still just starts working. I'll just say it orally. LFP, suppose you have to calculate. Then you are taking the minimum value in each. Okay, it works. Then LFP, if you have to calculate, then you are actually adding up the minimum value. Minimum value of F is -1. And then you are taking xi plus 1 minus xi. That is why this turns out to be -1 times the length of the whole interval, which is 1. And so LF, which has been defined to be the supremum of all possible LFPs, turns out to be -1. The value of UF is not the same as the value of LF. That is why, by definition, the function is not Riemann integrable. The same thing happens with your Dirichlet function. And it is very easy to prove using upper sum and lower sum than the tag thing, I think so. Where did I lose the question? Okay, I just remember the options now. I found the question. Yeah. Okay, so option C is wrong. Option A, is it correct?
By fundamental theorem, can we say that the first function is differentiable, so it is continuous?
Okay, great. Okay, so where is the fundamental theorem? Did I write it down somewhere? No, let it be. I wrote it actually, but where I wrote it, I don't remember. I'll just write it again. So the fundamental theorem says that this function f which you are writing, if something that is there inside is Riemann integrable, and you start at a, go to x. I don't remember the statement honestly. If you are having f in this form, then you can prove that f is continuous. And wherever f is continuous, small f, that would imply capital F is differentiable. What is happening in option A is the thing that modulus function is a continuous function. Half minus t is also continuous. So by composition, mod of half minus t is a continuous function. That is why this integral that you are taking, that is why it is integrable. And 0 to x mod half minus t dt, thus it will be continuous. And if you know the fundamental theorem, you can see even more that f is differentiable as well. So you just need continuous actually, that f is continuous will imply f is Riemann integrable. So the options given there they are also A, B and D, so they should be correct. Okay, you can go to the next thing, I think. They are coming slowly. Okay, my screen hanged. I'm really sorry. This is supposed to end at 12:30, so maybe we can end it now. Why waste time? When will this come?
Ma'am, you can leave and rejoin again.
Okay. I'll try doing that. Stop presenting. Can you hear me? Can you hear me?
Yes, ma'am.
Okay. Okay, next question, luckily. Uh, hmm. I hope this doesn't hang again. I'll use this full screen thing. Okay, it has hanged already. Just leave it. I'll try. Okay, you're supposed to find this limit. I won't be writing much. Any ideas or approach or anything? One thing is just try to put n tends to infinity. But what happens? You're having infinity into something. Maybe the answer is infinity only then. But what is inside is x power n. If you are having something of the form 1 by x plus 1, then when x lies in between 0 and 1, your x plus 1 is supposed to be bounded. In what sense? That if x lies in between 0 and 1, then x plus 1 lies in between 1 and 2. So 1 by x plus 1 lies in between half and 1. So what you are having is a function which is bounded. Along with that, you are multiplying x power n and just like integrating, right? So while integrating, whatever you will get an n extra down. And then when you are taking the limit from both sides, it is going to go to 0. So you are having something of the form infinity times 0. So you cannot predict it that way, right? So the limit may exist or may not exist. It is supposed to exist actually, and you are supposed to find it. So I have given ample amount of hint by this inequality or anything. Can you try to solve it and guess the answer or find it? We'll give you some time and try to figure out how this works. Okay, I can scroll down. Okay, so what I said, if I have to repeat it, I will repeat it. Consider x lying in between 0 and 1. The question is x power n by x plus 1 times n. Since I can write now, I will write. I just showed that 1 by 1 plus x lies in between half and 1. That is why x power n times 1 plus x is going to lie in between x power n and x power n by 2. Now, if I multiply with n on both sides and if I integrate with respect to x, after the integration, I will get n by n plus 1 times 2. Limits are 0 to 1. This is the question. N times integral 0 to 1. X power n by 1 plus x dx is lesser than n by n plus 1 if you put the limit. So the answer is finite. That's what I have only proved. That the answer actually lies in between half and 1 if you take the limit as n tends to infinity. So that is not the answer. So what can be done to find the answer? This is the question. It is finite. That's what I proved. Okay, any doubt in the proof of why it is finite? Well, this doesn't help at all to actually find the value, whatever I did. Okay, some more hint. That n is present outside, that is causing me problems because it is going to infinity. If that n was not present, I would easily prove that it would go to 0. So if I was able to take one n outside somehow from the denominator to cancel it off, then the remaining part could be easily evaluated. The answer is certainly not 0 because it lies in between half and 1. That's what I proved. So what should I do here? Have you learned about integration by parts?
Yes.
Let's try this. Was I audible the whole time?
Yes.
Okay. Okay, so somebody help me out. This is the question, okay? I'll write it down here. So I'll try, or okay, I'll try because time. I couldn't solve many questions in the end. So if you integrate this, you want to take as u, what to take as v. I want to cancel off my n. That can happen only if one n comes extra, and that happens when x power n is integrated. So let's take the v function to be x power n function. So u as it is, integrate v, put the limits, subtract, integrate, differentiate the first function, integrate again. Next, the question is n is also being multiplied. Write that down. Then put the limit, put the value. You get n by n plus 1. Okay, this was the n that I was looking for so that the part becomes finite. Then you put 1 and get half. Then, is this correct what I'm doing? Then you have plus. Then you have n, and something is again being integrated, but there is n times n plus 1, so I don't need to worry so much. You're integrating something. There is x power n plus 1 by x plus 1 squared dx. So now when I'm taking the limit, I am getting half plus some integral. Now we observe that integral. Like last time we were getting 0. So this time do we get 0 or not? That is the what happened. Okay, how do I use this? So try to, okay, just listen to me. So if you are having x power n function and you are going to, it came back. No, it's not working. Will it be? X power n function, 1 by x plus 1 the whole square. This is supposed to be bounded. if x lies in between 0 to 1, 1 by x plus 1, it would be lesser than half, I think. Is it? No, it's greater than, lesser than 1 at least. Isn't it? Then 1 by x plus 1 square would obviously be bounded above by 1. So you could take the second term to be lesser than this times this integral. Now listen to this fact that if you were to draw the graph from 0 to 1 of x power n, as n tends to infinity, that graph that is x power n is going to go to 0. That is why the area under the curve is also going to 0. More formally, if you integrated x power n plus 1, you will get x power n plus 2 by n plus 2 from 0 to 1. And that would be n by n plus 1 lesser than n by n plus 1 times 1 by n plus 2. And this will go to 1, this will go to 0. That is why this is certainly going to 0. That means that the integral of the second term is going to go to 0. First part is going to 1 times half. That is why the answer is supposed to be half. Is that clear? Or I think I need to repeat some part, I know. Hello?
Yes, ma'am.
Okay. Yeah. It's not responding. Okay. So the thing we did is we split it in terms of two integrals because outside there was infinity. I did not want to deal with infinity times 0 because of the by parts thing in subtraction. Whatever I could obtain, I could get an n plus 1 out and get the limit to be half, and the second part went to 0 because of some form of boundedness. So by parts works. That's the conclusion. Where is the next question? Okay, the question came at least. Okay. So I think the theory was also there about it. I'll just tell the theory orally, or if I find it, I might lose it. So maybe let's try to solve it. That's what at least the question came. Okay, you are having a function from 0 to infinity to r and g from 0 infinity 0 infinity. The theory that I gave above was the Leibniz rule. I believe that you know it. I'll have to do that now because I cannot find it. The Leibniz rule, okay, maybe I could. Or and the second thing that I wrote was the fundamental theorem of calculus. One of them is that the wherever f is continuous, capital F is differentiable, and the other thing is in the form of f of b minus f of a. So there are two of them, and my intention was please try to solve these either using Leibniz rule or by using the fact that the integral of f prime is fb minus fa, where a and b are the limits. I'm sorry, my screen is not working. Please try to solve this. At least help me finding f of 2 or maybe f of x. So I will ask you that what can I do with this?
f of x equal to
Mm.
2x by 1 plus 2x.
2x by 1 plus 2x. That's what you obtained. I obtained something different in denominator, but good idea. Like something like this only I would obtain. Here we are going to use the fact that the fundamental theorem of calculus, that since f is continuous, capital F is differentiable. That is why differentiate on both sides. As she said, 2x is going to come in the numerator. Then the answer is going to be f at b minus f at a, but your Leibniz, that happens only when the top part is x. So if it is a function of x, then the Leibniz rule works here, that first you are going to find the value of f at the upper part, then differentiate the upper function 3x square plus 2x minus find the value of f at the lower part, differentiate the lower function 0 plus the derivative of the inside, integral of derivative of the inside with respect to x. But since the inside part doesn't have x at all, that's why this part is also 0. So she almost got it, whomsoever it was, that the f of x turns out to be 2x by 3x square plus 2x. I'm sorry I couldn't show the Leibniz rule to you, but it is, if this is from ax to bx, then you are going to get something like f of bx times b prime x minus f at ax times a prime x plus the integral ax bx are there in the limits, the partial derivative of f with respect to t. But since it is not a function of x, we can ignore them. And we are getting this value for f. You could just even keep it in this one. Oh no, okay. I divided this. I'm wrong. I'm really sorry. This is not right, but this is f of some huge number, not f of x, but x cube plus x square. That you can say is 2x by something something, or maybe just keep it like this. That would be easier. So we have the following relation. Using this, can you find f of 2 and f of 12? What values do I put for x?
Ma'am, if we put x equal to 1, we will get f of 2, and if we put x equal to 2, we will find f of 12.
Okay.
Yeah, so we'll get f of 2 is equal to 2 by 5 and f of 12 is equal to 4, something like that.
Yeah, and there is something that is being multiplied also, and if you put x is equal to 2, then it turns out to be 3 4s are 12 plus 4, that is 16. So actually literally get 16 times f of 12 is 4. So one part is 2 by 5 and the other one is 4. Now you are supposed to find the value of g of x. So here will differentiating even work like last time? Or should you do that or should you not do that? I mean the Leibniz rule. And if not, then what can you do?
Instead of differentiating, can we just do t cubed by 3 and then put g of x?
Yeah, we'll do that. That only. So in this question, you could use both the things. Did I copy the question correctly? Wait a second. I think cube was there. Okay, now it is not working. At least something is working. I'll go with that only. This is G and that is 9. Okay. So G of x cube is actually equal to 27 times x plus 1 cube. That implies g of x is 3 times x plus 1. We have to find g of 2, and that is 3 times 3, which is 9. And the question was, I cannot scroll up, f2 plus g2 plus 12 times 16 times f12, and that turns out to be the sum of all these numbers, which is 9 plus 4, 13 plus 2 by 5, 13.4. That is the answer. I did have more questions, but I think it's 12:30 and I think we are supposed to stop, right?
Yeah, yes, Viona. Our time
Yes.
is
Okay. Yeah, right. Let's stop.
yeah, that's
I'm really sorry for the technical problems. I don't know.
it's, yeah, it's okay. Such kind of issues may always be there. It's a unavoidable thing in this type of online sessions. No problem. So anyway, I would like to thank Viona for this nice session with a good collection of problems. Okay, dear participants, now it is time. It is your time. You can share the feedback about the class, and also you can ask your queries with Viona. And also, yeah, of course, Viona may have something to share with you. She's yeah, qualified all these national exams and qualified different interviews. I think some tips can be, you can ask for some tips from her side.
It was really a wonderful session. The approaches for each of the questions, you were able to make us clear about all those things. Thank you so much for your time. I'm Anantram from Kerala, from 𝕗𝕗𝕗𝕗 Devagiri College. Thank you so much, ma'am, for your wonderful class.
Thank you. Thank you.
But we got some approaches, like how, in which all ways we have to try, like we got an idea about that. Thank you.
My name is Satya Krishna from Palakkad Government Victoria College. This session was very interesting, and we got many more ideas to solve some questions about differential calculus. And I hope you may add more videos and more classes for us. Thank you, Vinod, for this session.
Thank you, Aditya.
Hello, ma'am. I am Fatima Muhammad Ali from Associate College, Kannur, Kerala. So, ma'am, the discussion was more than a teacher-student discussion. This was like a friendly interaction. And yeah, the approach was very friendly, ma'am. Thank you for this approach. And we are looking forward for more classes, ma'am. And ma'am, can you please talk about the research that you're doing right now, the PhD?
I have not decided anything. Luckily, I took this because I want to use this year to decide what I want to do. So we have not been allotted anything. Yeah,
Okay,
so
ma'am.
just coursework for a year. Mostly analysis. I'm bad at algebra. So yeah, that's the only thing I know, analysis.
Okay, thank you, ma'am.
Hi, ma'am.
Hi,
I'm
ma'am.
Abarna.
Hello, Soumya. Hello, Abarna.
Ma'am, it was a great class. It was like interacting with our friend. He's clearing our doubts. Thank you so much for taking your time.
Thank you so much for your feedback. Hey, Aparna.
Hi, ma'am. Hi, ma'am. I'm Abarna.
Hello, Neetu.
I'm Palakkad.
Hello, Aparna.
Thank you, ma'am. Thank you for your valuable time. And the class was very interesting and understanding. And I class from you. Thank you, ma'am.
Thank you.
Hi, ma'am.
Hello, Neetu.
I'm Neetu from Kerala. First of all, thank you for your time and patience, ma'am. Hope we could use it efficiently in our upcoming problem discussions. And we are looking forward to attend furthermore classes of you. Once again, thank you, ma'am. I'm never getting bored of thanking dear Vinod sir.
It's okay. I'm really grateful. Thank you.
Hello, ma'am.
Hello, Prakash.
Thank you for spending your hello. Thank you for spending your time with us. In fact, you made most of the questions seem doable. Like you simplified the concepts for us and help us get those concepts fixed in our brain. So a big thank you for spending your time, and it was a great lecture. I definitely enjoyed it. Thank you.
Thank you. Mostly, I was trying to recall it myself for me, actually. Thank you. Yeah, hello, Anna.
Hi, ma'am. My name is Anna. Hi, ma'am. I'm Anna from Devagiri College, and I think today's class was really helpful to us, and it helped us to clear a lot of concepts in differential equation. And I am very thankful to the team, Maths Aspirants, and especially to Vinod sir for arranging such kind of section for us. And I think some topics are really hard for me to come up in this stage as a beginner, but I think I focus to be better in that. Thank you.
Yeah, differential calculus I also find hard. I usually skip it. But thank you, Vinod sir, for giving me this topic, and because of that, I could recall or everything. I still find those damn questions difficult. Thanks, Anna.
My name is Cher. I'm actually using it from another account. And ma'am, your class was very wonderful, and your approach was also very nice. First of all, you discussed the theory and then get into the question. That helped us a lot to approach the question. Thank you so much. And we expect your more classes in coming days. Thank you, ma'am. Then thank you, Vinod sir. Thank you so much.
Thank you. Tell me.
I'm Gayatri. I have done my graduation from Miranda House College, University of Delhi. The class was really nice. It was interactive, and we were able to understand the topic that you've discussed. Thank you so much for taking such a wonderful class. Thank you, ma'am.
Thank you. I had a friend from Miranda. She's in Roper now. Yeah, Anu Nanda was saying something like that. Hello.
Hi, ma'am. My name is Kannur. I'm from St. Joseph's College of Ernakulam. And we shared some theories that was very useful. And your session was nice, ma'am. Thank you for the session. And thank you, Vinod, for this one.
Thank you.
Hi, ma'am.
Hello.
Hello. My name is Srilakshmi. I'm from NIT Calicut. Ma'am, your session was really good. It was very informative. I also like the way of presentation. Thank you so much.
Thank you. Or whomsoever.
Yeah.
Yes,
I
Dharmendra.
am Dharmendra from Kasgunj, nearby Aligarh. I am also preparing for IIT JM also. I want to ask about some reference book, except 𝕬𝕐𝕚𝕐𝕚𝕚.
Actually, JAM, I am also not very good at. My rank was also around 400, 500 only. But maybe in any exam, what you do is, I am not good at reading books or anything. I usually just attack problems and then look for the theory maybe. Actually, I don't know, but Bartley Sherbet was really nice actually during my BSc. But maybe try, I don't know. Better not to give wrong advice, no. I can't.
Thank you, ma'am. Session was very nice, and every topic and every question theory also discussed between them. Thank you very much. Thank you, Vinod sir.
Thank you. Sorry, I don't know any books.
Hello, ma'am. My name is Susan. I'm from Kerala. The class was really interesting, and I love the way you teach it. And thank you so much.
Thank you.
Hello, ma'am.
Hello, Shikha.
Ma'am, your class was really interesting and interactive. And my name is Shikha, and I'm preparing for CSIR NET. So I want to know that what was your time management while preparing for CSIR NET exam?
Time management. Okay, what do I say? Like, you don't need to study a lot, I think, but just find out exactly what you are good at and just become very good at it. Like from where the questions will come, like in the sense, if you are able to find that. Means what I want to say is, if you are able to solve the NBHM and TIFR questions, then you can get NET questions. You may not be able to clear TIFR in the sense that suppose you are studying for JEE, you will clear CET, and studying theory is boring. So for me, it was that only. It might take time to think and realize. To do all the theory, I took like 2 months, 2 to 3 months, but just for solving those questions, just questions that also took equal amount of time. So yeah, it will take time, but I think the strategy that worked for me was not the theory part, but mostly solving a little more difficult question so that the easier questions you can solve there. Yeah.
Okay. That's nice
Yeah.
strategy.
May work, may not work for people. Yeah. Don't know.
Thank you, ma'am. Thank you, Vinod sir.
Hello, ma'am. I am Lakshmi. I am from TNG College, Tirur, Kerala. Thank you, ma'am, for this wonderful class. It was really interesting and informative, and you explained each and every question very clearly, and I got clear idea about this topic. And thank you, ma'am, for spending your valuable time with us. And thank you, Vinod sir, for conducting this class. Thank you.
Thank you for your time as well. Thank you. Thank you for your feedback.
Hello, ma'am. Good afternoon. My name is Sandana, and I'm from Kerala. First of all, thank you for this great session. We are all grateful for the knowledge that you shared with us. Once again, thank you for the effort and time that you put into teaching us. Thank you.
Thank you. Thank you, Vandana. I would like to thank Vinod sir for giving me this opportunity. I have never taught anybody, so it ended up becoming a discussion as usual. But it was really fun trying to teach. I'm sorry for the technical issues once again. It was really fun, even though I couldn't see people here. Like, teaching is like different, but still, it was fun.
Yeah, it's okay, Viona. And I request you to engage more problem-solving sessions in our platform in future too. Yeah, after I know that you will be having busy coursework schedule and all that in your research part. Still, while you find time, please try to be with us and engage some more sessions in our platform. It will be really a motivation and a great experience for our members. Thank you once again. Thank you, Viona. Thank you, everyone. Let us wind up here. Thank you.
Okay. Yeah. Thank you. I'll leave. Thank you so much again to all the participants.